afternoon, sir. How you doing?
I'm good. How you doing, Kevin?
Doing very well. There's a lot of good stuff going on. What have you been thinking about all this stuff with Walker and uh, all these other topics?
Yeah, it's the Discord is almost getting to the point where it's hard to keep up with everything. A lot of good conversation, and it's almost whoa, slow down. I was learning at a good pace, and now it's just a little crazy.
I
So
gave up a little while ago. I gave up a little
yeah,
while.
yeah, right, right.
Yeah, one of the things that I found really useful, and I think we're going to kind of get into it here, is that for the group of people that we've been working with more locally, Dan, Andrew, Mario, Dwayne, you, John, and myself, there's been a lot of learning from people with their own special areas, with their special focus, the niche areas that they focus in. So we've been learning a lot from each other, and I think that's what we're really doing here with you too, where you are bringing a lot to the table for creating a lot of these demonstrations to illustrate not only the technology, but what I really like about this stuff is that it illustrates the high level concepts, the principles, the best practices that we should be looking to execute in these kinds of IoT strategies and
Hmm.
solutions.
Yeah,
Mm,
yeah, no,
cool.
absolutely, absolutely, and it's just a great learning experience because
Oh
I'm
yeah,
finding myself in a whole lot of new areas as well that I never was.
yeah,
And,
yeah,
and a lot
absolutely.
of and a lot of it's that I couldn't. It's not like the information wasn't there. It's that someone says this is what you need to know in order to do this and focus on it. Otherwise, it's I have no idea even where to start. So, which is
Yeah,
cool. I like the direction.
yep, absolutely. Good. So, what do you have today? What are we going to talk about?
Yeah. So today, oddly enough, the theme is digital transformation. But it seems like everybody always wants to talk about, oh, we're going to put in cloud, we're going to do AI ML, or we're going to do some huge King Kong effort, and we're going to have lots of great dashboards and the like. And I maintain that you still need to you need to control what's actually happened at the device layer as well. You have to pay attention to it because what I have found is that a lot of people that try to do these dashboard efforts and all these things is that their data isn't quite ready to go. And this is taking a look at, okay, do we have some older equipment that we need to learn how to bring into a digital transformation? And if you think about the conversation that we had last week, just around, boy, what do you guys do at PLCs? And then I even just had an article that got published on ISA, one of the blogs about how do you teach an old dog new tricks. Well, I'm actually going to show some of the new tricks to some old, I want to call them old dogs because there's a lot of very good hardware that is still available that people have in manufacturing out in the field. And how do you take advantage of it without ripping and replacing everything? But if you decide that's the route you want to go, some things you want to take a look at. So before we get too far into this, just some shout outs. One of them is with Don Fitchett at Bin 95. He does a tremendous amount of training. I've been linked in with him for over a decade. He's just been phenomenal to help when I have PLC questions or just overall logic control. He has a lot of modules that you can just buy and training and the like. So if you're wanting to get into PLCs and learn how to do it, Don would certainly be somebody that I would recommend that you do. I was just going to do 4 PLCs today. I was able to get an Omron in at the end, a little CJ2M. So thanks to Jim Taylor at All Control. There's actually a client we're working on doing something with. That's sort of where this, actually the solution I'm going to show you is exactly what we're looking at doing with this particular client. But I appreciate them letting me borrow one of their PLCs. And of course, Salam at Optic22 on the Groove Epic. She's just been extremely helpful in getting some of the stuff done. And I'll explain why when we get there, because a lot of your logic control is it's pretty straightforward, but once you get into how they do it with their strategies and their charts, it's a little bit different animal. But once you get in there and understand it, it's like, oh, this is pretty cool. So that's what we're going to do.
Good shout outs. And I'll make sure to put those up on the screen as well and include them in the notes too, so that everybody can get some good credit. So it sounds like they're really good people
Absolutely.
doing stuff. So to kind of readdress or re-summarize the idea of what you're going to go through is within the context of digital transformation, helping companies go from industry 3.0 to 4.0, then the idea is a lot of those companies have a lot of old equipment. Not everybody has IoT enabled PLCs and controllers and whatnot. And so how do you actually work with that old equipment? Is that right?
That's exactly what we're going to do, and it's pretty basic stuff. What we're showing here, I mean, you can see this is some ladder logic. It's just a basic motor start and stop. I'm able to, and I can show you some of the hardware. Just so imagine that you have a controller where you're going to be at the local station. You're going to be able to operate it locally or remotely or turn it off. You have some start and stop, e-stop. So just imagine a panel that you'd have. So that's what your local control is. And then, of course, you also have the indicators that go along with it. I'll actually demonstrate this functionality once we get toward the end of the video. And then, of course, again, you can also do it remotely with through an HMI. And then you can just see we have the seal-in circuits for getting that all to run. So I've started here. This is a Micrologix 820. And what I'm going to do with this is I'm actually running a Kepware instance over here. So I'm now bringing all the tags in through Kepware. It's an OPC UA server. And I show this for a couple of reasons. One, there's a lot of people that use OPC and Kepware for getting tags out of their PLCs. So that's how I'm able to connect down to it. And I also want to show it because while I'm going to be publishing everything into an Mqtt broker, I want to be very clear that control still needs to be at that OPC UA or directly with that hardware itself. While yes, you can do control with Mqtt, really not recommended. So I just want to be clear on that. And the other reason why I'm using Kepware is they have this neat thing. It's called an Opc Gateway. That's actually what we're looking at, an IoT Gateway. And that's what we're looking at here. So these are the tags that I've actually brought in. So what we're doing is going from that Micrologix 820, bringing it into Kepware for publishing back out using the Kepware, the IoT Gateway. I'm going to get these tags publishing real fast. And what this IoT Gateway does is that it will publish in a flat JSON. So it'll take all of this information and it'll give you with the tag name, the quality, the value, and whether it's good or not. And I'll actually show you what that looks like over here when I'm publishing it to it. So I'll just do a little Kepware update. So now you can see here's the tag, the value, whether it's on or off, so true or false, and of course the time that it came through. So you can see exactly that we are publishing all these. I'll turn this off real fast just so we don't continue to update all that information. So now we're only going to, again, it's report by exception. We're only going to publish data changes. So now we're only going to bring in the data that changes through there. And so, what I'm showing you here is that when you actually look at the tag that's coming in, so we'll get down here. This is coming from my fictitious Highland plant. So now it's just bringing in this utilities, compressors, and here's the motor. And let me expand this out a little bit. You can see this is a pretty good sized JSON payload that's coming through, and that's the timestamp. And so what I'm doing with that is I'm bringing it in, running a Python script on this Kepware update, and anytime something changes, then you'll actually get a tag update entry. Not as elegant as some of the other solutions that I'm going to show you, but the idea here is that you can at least get this value published inside a unified namespace. Again, where you're coming down, you have your enterprise, you have your site, you get into the area, kind of a line, if you will, and what we're on. It's just a motor in this particular case. So, just one way of doing it, bringing in data. It's trying to make it available, and it's absolutely doable utilizing that solution. We've talked before about how there's other solutions that'll do it, whether it's OAS, open architecture, or using the Connect. They have their data hub. There's another products we talked about, the intelligence hub from Highbytes. It'll do all the same type of thing, running it through. But this is just a simple, real easy way to do it without bringing in a whole lot of software. So this is solution number one, using a Kepware with your OPC and publishing it using their IoT Gateway. So any questions on that? Oh, I guess I should show you that we can actually run this thing and turn the pump on and turn it off. So pretty slick. It's actually working. And then, oops.
So yeah, let me kind of throw in a few thoughts if you don't mind.
Sure.
So summarizing, a Micrologix 820, and then grabbing that data with Kepware, and then sending that data to an IoT gateway. And where was that IoT gateway again? It wasn't clear to me where it is. Is it in
Kepware?
It's in Kepware. It's in Kepware. And that Kepware is then publishing the flat JSON to Ignition.
Yes, it is. So I'm using just the Chariot SCADA ignition or MQTT server right here in Ignition. That's where it's all publishing. And you can
Okay.
see I'm only updating if something should change. So you see a lot of those tags disappeared when I just click the refresh. And that's just because this is the most recent data that we have. But you can see that it turned it on, it turned some stuff off, and what the status of everything is. So you can see all that. And again, it's nice that all of a sudden you can actually, through just a JSON, you can actually keep track of how often did a motor cycle through, or did a compressor start and stop, those types of things. And you get those times. You know the exact tag, on or off, and then anytime it changes, again, this will publish that data out to the broker, and you can subscribe to it, and then you'll have that data.
And so I have a couple other questions, and I want to be conscious of time so this video isn't too long for everybody. How many other samples do you have so that I know what level of questions to ask here?
In terms of samples, what do you mean by samples?
Like you said, this is sample number one.
I have five. I have five.
Okay.
Yes.
All right. Are they all kind of similar to this, or are they a whole lot different?
We're all trying to the whole goal is to demonstrate how you can use various technology in order to do a transformation on it. At the end of the day, they're all the exact same motor configuration, but I'm doing something different with the data, or how I'm doing it.
Okay, so it's how. But then the overriding principle is using these principles that we have around lightweight, report by exception, open technology, and of course there's always a fourth, and I can remember the fourth one.
Edge driven.
Thank you, edge driven. And execute using those as the some of the ground rules for putting these solutions together. Okay, all right. I'll leave more detailed questions for some other time.
No worries.
So let's go on to number.
All right. So the second one we're going to look at here, Kevin, is I'm using an Omron CJ2M. This is a workhorse PLC from the Omron family, and you'll see that it's got the exact same logic structure to it. So I have the first thing it does is the motor's, if it's running or it's not running, it'll say that the stopped pilot light comes on. I have the ability to do local and remote, and then of course there's the seal-in circuits that get everything to go. So you can see I can come in here, I can change it to where now the motor is going to be on. And of course, normally you would have just a push button that would do this. So that'll just, the seal-in circuit now continues to run it. And then of course, if I want to turn it off, I can just set that back. So what I'm going to do with this particular one is I've used a Maple Systems CMT SVR, and it has a pretty extensive list of drivers that you can use with these. So if you have a lot of old equipment, you can see that there, if you hit the right button, there is just a pile of drivers that it'll talk to in terms of hardware. So again, we're going to use this Omron driver here. And then of course, how it gets into, let's start with that first. So I built a screen here, just gives you some basic operations. So go ahead and do an online simulation. And as soon as that pops up, it's going to bring in all of the tags. You can see that I'm now stopped. I have the remote control, and now I can hit start, and the motor is running. It stopped. Motor stops. Pretty vanilla. So this is a good example of using a local HMI for doing the actual control of it itself. What I was going to show you earlier was that I can also take the Maple Systems and take all those tags that are in that Omron PLC and actually publish them to MQTT. And I'm actually using the Sparkplug-B protocol. So you can see that there's all the object properties. So I'm using Sparkplug-B. I'm sending it right to the Chariot SCADA MQTT that's right on the ignition instance that I have. And again, the group ID, I always use the, following through the ISA 95. And then I just take all of those tags that I'm pulling from the Omron, and I'm just publishing out there. That's all you have to do. So I can come over here to my ignition instance, and you can see that I have all of those tags. This is at the Arlen plant, sitting on the palletizer. I can see all those tags coming through, and I can actually go in and from my ignition, again, don't want to do control remotely, I can use that same MQTT, and I can start and stop the pump, so the motor. So if you see here, I'm now running. And if I go ahead and hit the stop, You come right back, you see that now everything is stopped. And it does keep track of every one of these. So if I were to hold down the start button, you can see that I'm actually holding down that start HMI. When I release it, that tag even goes through. So some pretty neat things you can do, but you can also capture anytime somebody actually manually starts and stops it as well. So if I were to hit the actual start push button and stop push button, if it happens to be scanning at that time, I can actually bring that through as well. So
So you're running two different HMIs, and you're controlling the one device through two different HMIs and effectively through that Mqtt broker.
absolutely. Absolutely. And the sweet thing about MQTT is it's outbound only. So I don't have to open up any ports in order to get this to work. That's just the nature and how that that protocol is built. Everything is outbound only. So whenever I make a change here, again, my broker happens to be locally, so there would be a little bit of latency there, but it'll tell it I have an update and it'll push it all the way out. So.
Nice. Nice.
So this is really of all of these, this is my favorite one, only because there's a lot of legacy equipment that Maple Systems can talk to, and I can publish it right in with SparkPlug-V. And I just demonstrated this. This PLC that I'm working with, it's probably been in the field 25 years. So next one I'm going to work with is a Siemens. So this is a Siemens S7 1200 that I have. That's sitting at my Danville location. So again, should be a very similar setup on doing this. So right now the motor is off. I can turn on remote control. I can go ahead and turn it on. So actually my PLC behind me clicked, and then of course this would normally be just a push button. So I'd change that back, and then of course I can go ahead and turn this one, turn everything off as well. So go ahead and get that turned back on. So exactly the same type of thing. So what I'm doing with this is I actually have an edge device. So I have a Raspberry Pi that is running Ignition Edge, and I'm taking all of those tags from it, and I'm publishing that through, again, the onboard MQTT transmitter. So it's a very common way of doing these types of things, just using an edge appliance. So just one more way of doing it. I can certainly bring up that bring up the instance of Ignition, but I'd have to launch that. And so again, here's the Danville. This is publishing it back out. It's on the coding area. It's on line 1. It gets the motor. You can see, just like we did in the Maple Systems, I now have all the same tags that are available to me, and I can do all the same motor type of control through there as well. So I can start it, and I can stop it, and you can see everything updates and tags. So again, within your unified namespace of having access to all this data at one consolidated location, because all these remote locations are feeding into one area, I actually have access to all of that data going back. So this one's pretty common in terms of just talking right to it. The S7's 1200 is still a very common PLC. It's available, so there's a little more that's that you can do with it as well. A lot more drivers and devices that'll connect to it. Not as much with, say, the Omron or that Micrologix 820. The Siemens S7 does have a function block that does support MQTT. You get 800 characters that it'll publish out. So you could go through and iterate through all your tags and build the JSON, and then you can actually publish it out, similar to what the IoT Gateway was doing in Kepware, and you can both receive on that same type of thing. But again, not as elegant as using something else. So I think there's still in development, but again, that's available on board with the S7 1200. So again, taking a PLC, putting it to Ignition Edge, and publishing it out via MQTT. And of course, you can develop all of that, develop all of the windows right there on site through that edge device as well, if that's something you need to do. So any questions on that one?
No, I mean, you're repeating the same pattern in effect over and over again, just with different devices, demonstrating the different devices. So you go to Siemens S7 1200, or maybe I do have a question. But you are also using a Raspberry Pi with Ignition Edge. So where do the two come into play as you're pushing the data out to the data broker and Ignition, and then showing that and controlling that with the HMI and Ignition? So
Yeah. So the Raspberry Pi is sitting on the same site. It's sitting right next to that S7. So yeah,
okay.
architecturally speaking, it's at that remote location. I'm using Raspberry Pi. I have the drivers within Ignition pulling the tags right out of that Siemens. And then I'm also using the MQTT transmitter and publishing those tags to an MQTT.
So you're using the Raspberry Pi as an edge device connected to the Siemens to pull the data out of the Siemens. You're not. They're not.
Yes.
Yeah.
Yes. Thank you. Yeah, it's a great clarification on that. So Ken, so now we're looking at something that's a little bit. This is definitely a piece of hardware that is Industry 4.0 ready to go, and this is an Easy Rack PLC. And they actually they have a spark plug driver right on it itself. So again, Easy Logics and Easy Rack, they have both PLCs and HMIs, and you can do all the same, the same control would be there, the PLC, you need to have a local operator that's connecting through it. But what's nice, again, I don't know if I need to demonstrate the functionality. This motor is going to do the exact same thing. But you can come right in and do your Spark Plug B setup. So you have your client ID, you give it to your unified namespace. So here in the Springfield location, we're in their fermentation area. And then I set up what just the brokers are, get that all set up. And then all the tags, all I have to do is just publish what tags do I want to do. And I can actually bring in that unified namespace exactly how it is. Tank 103 on pump 1 filling it. There's all the tags that are available to me. So anytime I make that change, oddly enough, let's go over to the Mqtt Broker. I can pull up the Easy Logic screen, and you can see that I can start and I can stop that motor just like I can. So, again, the point isn't to actually do remote control for all these devices. The reality is that, since I built this out properly, we're now at the Springfield location. I can come into my fermentation area. I can go to tank 103. I can go to the charge pump that's going on it, and I have all those tags available to me. So when I start it and I stop it, it does all the same thing. So, variation on a theme, but again, if you're taking a look at, you have some older technology that's, we would like to replace it with some new stuff. This is something you want to consider. So, starting from a technology first standpoint, it's okay. We want a PLC that is going to support MQTT, Spark Plug B, and that's what we want to have on there. And of course, there's many other considerations you'd want to have, but this is something that Easy Logics does. So don't have to do anything with it. It's all ready to go.
So the UNS, the Unified Namespace that came out automatically, like how was that created? Can you just review that? Again, where's the other screen you were showing? Where was that?
Yeah, so it's over here. So when I go to my
rack. Yeah, that's right.
I mean, the Easy Rack. So when I go to my PLC setup, or my spark plug setup, I actually can bring in all of the tags that are available to me in that PLC, and I can actually publish them exactly how I would want them to exist with inside a unified namespace, or at least in this particular instance, how it would look.
And so where did you do this in this PLC designer? Where did you set up that structure?
So this is so I'm in the PLC. This is the development environment for the Easy Rack PLC. And there's just one on the communication setup. If I go to Spark Plug B in the setup, it's just, this is where I just give it the general setup, use my group ID, node ID, and device ID. I happen to use those three for the enterprise sites and area. And then over where I've published the tags, it automatically fills those in. And then I can even get into line and cell, if you will. So, again, it's on tank 103 in the fermentation area. And I'm pump 1, so it's coming into that particular tank. That's
okay. So then, for each development environment, for each HMI, each development environment for the logic for the PLCs, you have to identify where you're going to put each of these components, enterprise, plant, etc., for the UNS structure, and then put them in. It just creates it from there, and then you're pushing.
Yeah, exactly. Now, again, if you were looking at a complete development environment, it's something that you might want to create your entire unified namespace for that actual location itself, and then just have a folder for, say, MQTT tags, and that's where this would go. I'm really just demonstrating this to show that you can publish this data right to a unified namespace using that hierarchy that would make sense. But it's more likely you're going to build this within your plant itself and then publish that. That's actually something we're going to take a look at near future. Is actually building one of those for a site and then publishing it into an enterprise. So we're going to take several individual MQTT client or brokers, and we're going to publish that using a bridge connection and putting it into a cloud MQTT.
Nice, great, awesome.
So that's what we're going to look at. So, again, just going through, we had a Rockwell PLC, put it into Kepware, went into their IoT gateway, and we just published a flat JSON. Does give us the same information. Second one we did was that Omron PLC, went into the Maple Systems SVR. We're able to do all the control there from that particular unit, as well as publish MQTT, in that SparkPlug-B format, so it's available with another systems. And then again, we had the Siemens S7 using a Raspberry Pi that's running Ignition Edge, so you can do the control right from that Edge device. And then it also publishes into the MQTT broker, and you now have all that information available however you want to consume it out there. So.
And you did the Easy Rec PLC.
Then the Easy Logic's the one we just visited here. This actually has SparkPlug-B built into it, so I don't have to do anything. I just build my project, and then I am off to the races. So I can take all those tags and publish them right out if that's how I choose to do it. So they're pretty darned inexpensive too. So something we want to take a look at, functionally speaking. All right, so now we're going to come to the Opto 22, the Groove Epic. And what is fundamentally different about how they do their programming is that instead of using ladder logic, they actually create these strategies, and then they create these charts. And so what a chart is it's just a visual flow diagram of the logic that you want to run through. And so every chart starts with this power up chart that just starts everything, and then you give it in the next signal, the next flow, just to go ahead and start the charts. And so what I've built here is that I've broken down each of those rungs that existed in the other PLC programs. And the first thing it's going to do, and it's running all of these charts at the same time, is that I'm just going to, if the chart is going to start, I'm going to check to see if the motor's on. If it is, I'm going to turn the pilot light off. If it's not running, I'm going to turn the pilot light on, and it's just going to continue to run this particular chart. Next thing it's going to look for is it's going to start the chart. It's going to see, am I in local mode? And then you can just follow it through. If it is, it turns the local PLC on, or it'll turn the local pilot light off. And then it's going to look for the stop push button. It's going to look for the start push button. And then it's just going to continue to loop through that exact same scenario. Remote ones, the exact same thing, but instead of looking for an actual IO change, it's going to come in and look for it's going to see, did the IO change for that? Are we in a remote operation? And then I can start and stop it with an HMI, and then it'll just do the logic there from or it'll do all that. It'll solve for that and just reiterate it. And then finally, using that same bottom rung with all the seal in, it's now going to say, can I run the motor? Meaning, is one of these states true on the others? Is it time to run the motor? And before it does anything, it's also going to check to make sure, is my e-stop off? Is that emergency stop there? Otherwise, it'll turn the motor on, and it turns on the running pilot light as well, and it'll just continue to run this flow as well. So a very different take on how you would do the actual PLC control. I'm pulling in all of the tags that I do have, so the actual IO that's coming from it. And then I've also created some variables, so instead of a memory tag, you use a variable in order to do the same type of thing. So any questions on using the PAC for doing this?
No, that's a really different way to do the programming. That's really interesting.
Yeah, it is. And once you get used to it, and again, Salam spent some time with me just to really help me understand exactly how you want to develop these. Because once I figured out the ladder logic, that kind of made sense to me. This took a little bit more doing, but again, it's like using RPM on a calculator. Once you get used to it, you're like, wow, this is a pretty sweet way of doing it. So they also do have a visualization, that environment that's in there, and this is right on the actual Epic itself. And so we're going to get into all the myriad of ways you can take the logic that's on this Epic, on the Epic device, and actually run through it. So we're going to go ahead and we're just going to start the Groove view itself. And you can see I have all the exact same lights that you would expect to see here, but I actually have this wired into some RO or to some IO. So we're actually going to show that I can turn this on, and I now have local control. You can see that my yellow light is in on my controller. I can take the green button, I can start the motor, and now you notice that the light changes. It's still in local control. Now I do have a blue button for doing the shut off because I didn't have all the ones that are there. So go ahead, I can stop the motor as well. And then of course I do have the e-stop, so we'll go ahead. And not as easy to do when you're trying to do it with two hands, but I can actually get the motor stopped as well. So I can get that all the way in. So now the motor's stopped. What's that?
No, so can you juggle a mouse, a computer, and input devices? How much can you
do? Yeah, I'm showing that. So now I'm going to put it into a remote mode. So you can see now the remote mode's on. Motor is stopped. And now that I'm going to control it with push buttons, it's a little bit easier to do. Just hit the start button, and the motor's running. Hit the stop button, and the motor's stopped. So I also happen to have one of their ICTDs. Start broadening temperature just for fun. So you'll see something a little bit different. But again, this is a visualization that exists right on the Epic itself. So which is pretty cool.
That is really cool. You're doing a lot of really, really nice stuff with this.
Yeah. So if that wasn't enough for you, that you also have the ability that, remember we talked about doing Node Red?
But wait, there's more.
Yeah, but wait, there's more. So you have Node Red you can do this in. I didn't build any of the flows, but I'm just demonstrating that you can do stuff with all of this. It does have all those same Epic inputs down here. So all the Opto 22, you can pull in all of that IO that you want to use utilizing Node Red. But if that wasn't enough for you, it also has a built-in ignition instance.
And so we have a set of knives for you.
Yeah, right. Yeah, so it has onboard ignition where I can actually develop that, develop this particular project, taking all that IO and all those variables, and there's a driver that it brings in similar to it, so I can actually do all this remotely as well. So I can come over here to my project, and again, here's my Groove Epic, and there's actually a couple of ways that this has come in. Oop, let me get to my, so this is at the South Park location. So I can come in here. I pretended this is a refinery, so we're out in the alkylation unit. I'm actually using the Opto MMP, so this is all of its onboard. You have all the channels. You can see all your e-stop and all your pilot light. Let me move this over a little bit, so you can see lab temperature. It's 20.3 degrees C in here, and you can expand out all the same IO that's there. And then of course I did create another connection into the actual the pack configuration. I'm bringing in all that logic and that control, so you can see I have all the same kind of data that's coming into it as well. So again, as you would expect, I can come in here, I can start it. And now it's not going to work for me yet. Oh, I need to run the strategy. All right, it's back on. Well, this was working great earlier, and I'm not sure why it's not. But nonetheless,
we get the idea.
Yeah, right. So again, the whole point is that here's how you teach an old dog new tricks. Here's how you take some existing hardware that's out on your even in your manufacturing site or even remote. There's several different ways that you can connect everything together, and then you can bring it into a unified namespace. We now have access to all that data. Again, using all the core principles of the open architecture, lightweight, report exception, edge driven, and all of this information is there. So.
Yeah, again, like I said at the beginning, I really like the idea, the fact that we're using these if you might, newer principles for creating really good IoT strategies and solutions for a lot of the flexibility, scalability, for getting that one version of the truth out to everybody for that visibility into the plant. And at the same time, you're enabling this with existing technologies. I mean, that's something that we're working with for some clients right now in conversations you and I have had separate of this conversation here, where they've got a lot of, I think I was talking with Tim, 4 or 5 different models of Rockwell Automation PLCs and RS Logics RS Links isn't cutting it anymore, and we need to at least replace that with Kepware to pull the data out and then push it into HiByte and an Mqtt Broker to really get the data where it needs to be, and that's going to save us a ton of time versus what we would have done, previously with older technologies. And the PLCs don't need to change. At some point, they might need to be updated, upgraded, etc., but we don't need to touch them, and we can still do this much better. Let's call it higher level, more flexible IoT strategies and tactics. It's awesome stuff. It's really good.
Absolutely, yeah. So I am able to control this thing just by manipulating the tag value itself. So apparently, a little like action item that I have behind that tag, even though I had set it up and it was doing its thing, something has changed since then. So yeah, a lot of different stuff we can do here. I guess there's one other thing on this this groove that I wanted to show you.
But wait, there's more.
Yeah, but wait, there's more. So yeah, so I mentioned Ignition. Again, there's an Mqtt broker that's built right into it as well. So that's where we're getting all the payloads. So similar to the Easy Logic, you're able to publish right to it. And then, of course, it also does have a code assist on here as well. So if you wanted to use code assist to do all this, it supports code assist as well. I haven't done anything with it, just pointing out that it is there. So it's just another way of doing it.
So the Groove device has an actual Mqtt broker inside this device that's at the edge, so to speak.
Yeah, absolutely. And
exactly. Getting back to that idea of the flexibility of the brokers, where you can have them at the edge, on the line, at the plant, at the enterprise, and they can all publish, and it's all based on whatever kind of problems you're trying to solve as to which ones you set up.
Yeah. And you just have to say, do I want public access to it or not? And you say, yep, I do. And then it just publishes it right out. So, and then of course I like it because it's got a wiring diagram built right in. So when you're going to wire everything, it's pretty slick. So just a lot of functionality and flexibility to it. And it's actually priced pretty darn competitively relative to other PLCs that are available on the market. So a lot of different ways we can do something, but definitely you don't have to get rid of your existing hardware. You can already use what's there, but if you decide that, yes, technically speaking, we're due for an upgrade, these are some of the things you should consider in terms of how you do that.
Amazing flexibility. And this is also the kinds of solutions that you can start to implement incrementally. You don't have to do all of this for all of your PLCs and all your devices. Just do a couple.
Yeah, absolutely.
Do an area, do a style, a line, and then more later.
Yeah, so going back to this Omron one, I mean, we're just going to start with one machine. Obviously, this isn't. There's a whole different program that runs with it, but all we're having to do is plug in this Maple Systems. We're going to use an SVR. It's actually a 200 for that. It's got a Wi-Fi built into it, but it'll connect right into that Omron PLC, pull the tags, and then they'll now have what they're trying to get at is they want to be able to remotely pull some data off of their machines and see what's going on. So that's what we're doing there. But it's $300.
Wow, priced right. Crazy levels of flexibility.
Absolutely.
Scale for the future. Good stuff. Wow. Anything else? Come on, don't you have something else?
Yeah, no, I think that's pretty well it.
That's enough.
Yeah,
that's
I think it's enough. Definitely is enough. I hope it's enough.
It's plenty. It's more than enough. So you've gone through five examples, and again, like you had said, just demonstrated how to pull the data out of older devices into the, let's call it the new architecture. Following these strong principles for IoT, yeah, the IoT strategies and best practices.
Yep.
Yeah, awesome. Great stuff, Dave. Great stuff.
Oops.